Okay, so on the way in, you picked up your note page for 8.1, defining and using sequences and series. That's what this chapter is all about. I've tried to put all the examples and monitoring progresses that we're going to use on into this one little packet for you. Okay, so if you take a look at this, we're going to just kind of treat this using, I want you to do what you think you should do. Like if you just ran across this problem and it was a test and you couldn't ask anyone for help, or you can ask at least the teacher for help, what would you do if I gave you, and let's just focus in on part A here, to find the first 6 terms of that sequence? What would you do? If you're like, I don't know what I do, well, try something. What do you think you should do? Okay, I want to know what comes to you intuitively. All right. So A sub n, this means you are finding what this value equals when n is a certain number, like the first term of this pattern. When you're dealing with a sequence or a series, you're dealing with specific terms of a series. So the first, or specific items or specific place values. Think of that way. So when I say I want the first term of this, I'm going to say n is 1. So a sub 1 is equal to 2 times 1 plus 5, or 7. The second term would be a sub 2. It would be 2 times 2 plus 5, or 9. Okay? Now generally when I'm writing these out, I don't usually write them so much like this. I would probably write it in a table format. It's the format I like seeing them in more so. Where I'm just saying, okay, 1, 2, 3, 4, and 5, and 6 here. Okay? And a sub n is equal to 2 times 1 plus 5, or 7. And that's 9. Well, this is just linear. So what's going to happen every time? It's going to go up by 2. Okay? 2 times 6 is 12 plus 5 is 17. That would be a good way to write it. It also allows you to then think of it as, well, really, if I'm having to graph this, which you eventually will, really this top value is my x value and this bottom value is my y value. If you're trying to relate it to x and y on an axis. Okay, so if I was to graph this, it would just be a linear equation. But here it's just saying write the first 6 terms. Okay? I want you to do that for part B if you haven't done so already. Write those first 6 terms for part B. All right, let's check our work for part B. Any questions there? Please note one of the patterns you see, f of n is alternating positive, negative. Notice that happens when you have powers, right? If you have the even power or an odd power, okay, when I put 1 in here, that gives me what we think of as 0, which would be neither even nor odd, but a lot of times you think of 0 as even. You put a 2 in, that's 2 minus 1, that gives you an odd power. 3 minus 1 is squared. Makes it an even power. It flips those signs around. Okay. Any questions there? We're really trying to build into doing some of the tougher stuff here. Okay. So, easy, hard so far? Easy. Okay. If you want to do the other ones, you can. If you want to do 1, 2, and 3 when you have nothing to do here in a while, you can. But I want to move on to example 2. Okay? Example 2, describe the pattern and write the next term, and then write a rule for the nth term. Okay, notice there are 2 different patterns here. Let's start with the first one. Part A, -1, -8, -27, -64. So, figure out the pattern and try to write a rule for it. Okay, talk to your neighbor about it. Have you figured out the pattern yet?
I have not. Thinking maybe the first value 1 would be negative 1, 2, something like that. You know what I mean? But then I was like, no, it doesn't really make sense. So on to the fourth. So the fourth value is negative 4 cubed.
Okay. Hey, so here's one thing that you really need to take in. You are always trying to relate n to a of n. Okay? So right now, one thing that will start helping you if you're struggling with this, and even if you're not, they're going to get more difficult. Please start thinking of this as we have n and we have a sub n. A sub n, they tell us negative 1, negative 8, negative 27, negative 64. If you can kind of put it in this context and say, well, n is just what number of the pattern are we in? 1, first term, second term, third term, fourth term. Okay, you are really, when you're trying to write your rule, you're trying to relate this to that. How do you get from here to there? Okay. So, how do I get from here to there? Yeah. Okay. So, good. So, some of you may recognize right away, hey, well, here to here, there's a lot of things. But 2, well, I can multiply by 4, but that doesn't work here. Okay, I could add 6, but that doesn't work here. I could cube that. Hey, and that works there, and that works there, as long as I make sure that when I'm cubing it, what am I actually cubing?
The opposite.
The opposite of it, right? So I have to, because it has to be negative. So it has to be negative n. So if you want, sometimes when I'm trying to figure these out, you'll, like even on my answer keys, you'll see me right up above here go, well, negative n is negative 1, negative 2, negative 3, negative 4. I usually wouldn't do it for that, but if that helps, write it down. You're like, well, if I write it as negative, well, now I have that, and to get to here, if I cube that, that gives me, yeah, it gives me that. So each time. So a sub n is equal to the opposite of n cubed. Yeah. You could write it like that. Put the negative on the outside would have been fine on that. Yep. It wouldn't change on an odd power. Yeah. Okay, so if I'm finding the next term, what's the next term going to be? A sub 5.
Negative 125.
It's negative 5 cubed, or negative 125. Any questions there? Okay, so hopefully from that you can learn, we go in and say, okay, really what I'm thinking of when I'm looking at part B, the first thing I should do is maybe right up above it, unless, I mean, you could rewrite it as well. But a lot of you, as you're showing your work, you're going to go, okay, that's the first, that's the second, that's the third, that's the fourth term. How do I get from here to here on each of them? So I like to rewrite it a lot of times, so it makes it a little cleaner. This one's a little tougher. How many have already figured it out? Okay, good. Okay, someone that figured it out, can you walk me through your process? If you are someone that just went, oh, I just recognized what it was, then don't tell me your process. But someone that trial and error. Zach, what'd you do?
Okay, so I looked at it and lining the numbers up. And I noticed that 0 is where like the 1 would be, and I know that you can't have like a power that leads to 0. So I knew that there would be a subtraction in the power part, you know.
Okay.
I actually don't know if my thing is even right. I said that it was a to the n minus n power.
A to the n minus n? Close. Not quite. So you notice that like the 0, this 0 should have been somewhere else? Or is that what you're saying?
I just meant that like you can't have a number to a power that would equal 0.
Okay. So you're in power form right now. Doesn't always have to be powers. It can be. I'm not saying it's not either, Zach. So, Rory? It could be. It's not in this one, but it could be. You can have patterns like that. Sylvia?
I started by doing the degree of difference thing where you see the change levels. And so I thought that was a second level change, so second power.
Okay, so you started by finding the difference here. To figure out which, good, so you said this is 2. I go up by 4 here, and I go up by 6 here. And that's 2, and that's 2, so this has to be a quadratic. Anyone else look at it like that? It's a good strategy. Right away, you know it's a quadratic. So, Zach, you thinking of powers? It was right on. So somehow I'm going to have to use a quadratic to get there. It's obviously not n squared. Okay, I'm going to pause right here. Dallas? Okay, but how? Okay. Cool. And Sylvia, where'd you go from here?
I was trying to figure out what would make 0, because like Zach said, that seemed odd. And I tried numbers, and that didn't work for me, so I eventually went to n squared minus n.
Okay. So this right here tells us the degree 2, second degree. It's a good route to go, so we know it's a quadratic in this one. Okay. We know, as Zach has said, we've said that a lot of times, as Zach has said. Well done, Zach. Okay, so from here we look at it and go, whoa, that's kind of weird to get a 0 there. So maybe we look at here, like 2 to the second is 4. Okay, well, 3 to the second is 9, 4 to the second. Okay, how am I getting from each one of those to this number? Okay. And your pattern, you ended up saying, well, you're doing n times n minus 1, right, Dallas? Is that what you said? Is that what you came up with?
Yeah,
or did you put n squared minus n?
Yeah.
Okay. Okay. Notice if you look at, these are the same thing, but if you're figuring out the pattern, they come out in 2 different ways when you're really starting to think about it, right? Because in one way, when I look at this, I go, well, I know it's quadratic, and 2 to the second is 4, and I have to subtract 2 to get here. So really probably what I would do is I'd say, well, I know it's quadratic, so that's going to be 1, 4, 9, and 16. And to get from here to here, I'm subtracting 2. From here to here, I'm subtracting 3. From here to here, I'm subtracting 4, which really is I'm taking n squared and subtracting n. I'm subtracting this value each time. Okay? Now, that actually gets me right here. Dallas, you said this, right? So how did you think of it to get to n minus 1? Okay, so you just kind of like guess and check after that? Okay. So you're like, well, 1 times something, and I got to subtract. Oh, hey, that just works. And 2 times 2 minus 1 is 1. Okay. 3 times 2, 4 times 3. Okay. So that's n minus 1. So the next one would be 5 times 3, which would be, or 5 times 4, excuse me, which would be 20. And then 6 times 5, which would be 30. Okay, which is the same way as doing 25 minus 5, or 36 minus 6. So there's multiple ways to get to these patterns. Okay, and either of these answers would be fine. It's just how you're thinking through the process. Confusing? Yeah, it can be confusing. Okay, the first step, though, really that helps us is to figure out that it's degree 2. Okay, how many are with me so far? All right, I want you to try example 3. Just so you know, it's kind of hard with this, even in the book. This is 1, 4, 9, 16, 25, 36, 49. Okay, there's 1 in the first layer, 4 in the second, 9 in the third. Okay, in terms of your layers. So first layer has 1, second has 4, third has 9, fourth has 16, fifth 25, sixth 36, and then the seventh is 49. Just so you know, that rule should be a lot easier than our previous one. What's our rule? A sub n equals
N squared.
Yeah, n squared. Okay. What's the graph going to look like? It's going to be kind of a quadratic, right? Now, when I'm graphing this, if I'm graphing it, this is discrete data. This is not continuous. Remember, there's not like 1.5 rows. Or n cannot be 1.5. So it's discrete. You don't connect these points. It's not continuous. Notice I only have half of my parabola. Okay? Well, I don't have the rest. Matt? Yeah, you don't have negative apples. You don't have negative layers. I know. Sad. It'll be kind of cool looking apples. Maybe. Use your imagination. I don't know. All right. Hey, any questions so far? Tell your neighbor what's the hardest so far. What's the most difficult piece of this so far?
Yeah.
Okay, what's the most difficult? Most difficult. Figuring out the equation. Well, good thing we have some practice problems here. 4 through 7 on the next page. Only because that was the most difficult. Okay, give number 4 and 5 a shot. So I like to just write it out like that to begin with. Okay. Hey, I'm increasing by 2 each time, right? So this is a linear pattern. Okay. Anyone figure out the pattern? A couple of you? What do you got? 2n plus 1. How did you get that? Okay, so since they increase by 2, your slope is 2, right? I mean, you can use some of our algebra skills. Our slope's 2n. So if I double this and then add 1, I get to the next number. Yeah, good. All right. Anyone get the next one? Is it linear? No? Is anyone trying what Sylvia suggested on the first problem? So it really is a good strategy if you can't recognize right away. Like looking at your differences, that's 5, that's 7, that's 9, that's 2, that's 2. This is a quadratic. So I've got to square this somehow. So I'm just going to write up another row right above this. Say n squared is 1, 4, 9, 16. Now I'm going from here to there. What am I doing every time? Here I had to I square it and add 2. Square it and add 4. Square it and add 6. Square it and add 8. Yeah. Yeah, you're adding twice as much of as this, right? So we get n squared, and then we're adding 2 of these. Okay? Yeah, plus 2n. The other way to think about it, some people may have wrote it as, if you looked at it in a different way, you may have said n times n plus 2. So 1 times 3, 2 times 4, 3 times 5, 4 times 2, 2 more than 4, 6. Okay, so the next one would be 5 times 2 more than 5, or 7, which would be 35. Same thing as 25 plus 2 of those. All right. Everyone rate themselves 1 to 5 right now. 5, you're getting it. 1, you're really struggling. Okay. Guys, this, I don't expect it to be way, way easy. It should be a little challenging for you. Okay? Try 6 and 7. I'll be walking around. If you have questions, make sure you ask, please. I personally think probably number 6 is the toughest one. I think 7's a little easier. So if you're sitting there racking your brain on 6, maybe go to 7, do that one, and then come back to 6. Okay. Okay. So the one I think is easier of the two. Once again, if I figure it out here, this is 3, 5, 7, so 2. This is a quadratic. Okay, second degree. So if I have n, and then think of n squared, I'm going to kind of run out of room up here, so I'll erase that line. Okay, so if I write my n squared above it, 1, 4, 9, and 16. From there, it looks a little easier. To get from 1 to there, it looks like I'm just adding 1 every time. So if I take n squared and add 1, I'm good to go. Okay? This one's a little tougher. Okay, so if I write in my n, who got this one again? I'm just curious. Man, really good job. Okay. All right. Well, if I go right here, I go down 3 and then up 6 and then down 12. And then this is not going to work for a quadratic or linear. That means it's some other type of pattern, usually some other degree. Well, one thing to keep in mind here when you're looking at this and it's switching signs, that means you're probably dealing with an exponent, and you're raising it to a power, and that could be or you could be multiplying by -1 at the end or at the beginning. So thinking of it in some way like that. So when I'm taking a look at this, if I'm going 1 to what power, 2 to, is there any particular base I'm dealing with? Like 2, 4, 8? Yeah. -2 base? Okay. Yeah, if I just ignore the negatives, I'm dealing with base 2. Everyone see that? Okay, so this would be 2 to the first, 2 to the second, 2 to the third, 2 to the... No, that doesn't work. This is actually 2 to the what? This is 2 to the 0, and this is 2 to the first. If we're just ignoring the negative for a minute. This is 2 to the second, and this is 2 to the third. Okay, well, if I want the negatives in there, so I've kind of at least figured out a pattern. If I want the negatives, this would actually have to be, to get that -2 here, this would have to be -2 to the first. Which means this is -2 to the 0. Does that still give me 1? Yeah. How about negative 2 to the second? Does that give me 4? Yeah. Negative 2 to the third, does that give me 8? Yeah. Negative 8, right? Okay. How do I write this up relating this power to n? We've got to relate it to n, so we know it's negative 2. Emily? Yeah. Yeah. Notice the first power, that's this. That one ends up right there. That one's right there. That one's right there. So if I'm going backwards, I'm taking away 1 every time. So I'm taking n and I'm subtracting 1. So if I want that number, I'd have to take the first and subtract 1 to get n to the 0. Or excuse me, negative 2 to the 0. Really good job. Okay. Questions? We're about to shift gears. Yeah, man. Summation notation. All right. Before we do summation notation, let me relate this. Let me relate this to what we've been doing. Right now, I want you to think of this as n and think of this as a sub n. What are you doing? Ignore the pluses for a minute. Okay? Just what are you doing to get 25 to 50, 75? What's happening? What are you doing to n to get a sub n? I guess we'll go dot, 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 and then we're over here. Okay? So what are we doing to n? Multiplying it by 25. It's 25n, correct? All right, so that's the first step. Not difficult, correct? Summation notation is saying, look, I want to know what the sum of this is. And the way we write it is like this. We use this Greek symbol called sigma. So we're going to put that out in front of it. We are starting when n is what number? 1. We're starting with the first term. And we want to find the sum till, what term would this be? How do we know it's 10th? Tell your neighbor how you know it's the 10th. Okay, as Kenzie said, because 25 times 10 is 250. I don't know if she said the 250 part. I heard. Oh, was it Sammy that said that? Oh, good job, Sammy. All right. There we got it. How do we read that? That it says the sum of, maybe write this down, the sum of 25n for values of n equals 1 to 10. So let me say it again. The sum of 25n for values of n from 1 to 10. Did I change my wording? I'm sorry. The sum of 25n for values of n from 1 to 10. Did I say it the same way that time? What did I say the first time? Oh, equals. I'm sorry. Thank you. All right. Hey, we wrote it in summation notation. That rhymes. Yes? No. All right, try B. Try B. Remember how we started it. Try to relate it like we've done all the other ones. All right, tell your neighbor what you got.
Yeah, that's not true. I didn't use it. The cool thing that you did.
Did everyone get n times n, or no, n over n plus 1? Okay, n over n plus 1. Hopefully we recognize that pattern. Okay, where do we start? At 1. Where do we end? Yeah, we never end.
What do we put?
We use the infinity symbol.
That's so fun. This one has all sorts of little symbols.
Woohoo! Yeah, man, the sideways 8. We're going to use all the cool math terms. Yeah, keeps going forever.
A lot of time on their hands.
Cool, huh? All right. Okay, I want you to try 9 through 12. 9 through 12. I'm waiting. Hey, there's number 9. This one goes on forever, so we have infinity. This one's tough, man. N squared over n squared plus 1. Well done. Yeah, nice job. Okay. Oh, yeah. This one is what? 6 to the power of n. Okay. N equals 1 and infinity. Last one, n equals 1. Looks like each time we are adding 4, that would be 8 plus 4, so we're going to 8. So we have n plus 4. And you have to put parentheses around that because you're adding a term there. Make sure you put that parentheses in. N plus 4 in parentheses.
Is 4 plus n okay?
4 plus n would be fine. All right, we'll pick up from there.